Hi everyone, in today's study we are looking at numerical analysis. We want to see what is referred to as Newton's forward interpolation formula, and it is given by y of x naught plus u of h is equal to y naught plus u of forward difference of y naught plus u bracket u minus 1 divided by 2 factorial second forward difference of y naught all the way to the other terms. Now here, u is equal to x minus x naught over h, whereby h is the equal distance from the first value. So the focus is to prove. So in order to prove that, we are going to let y to be a function which take the values y is equal to f of x is a function which take the values y naught, y1, y2 all the way to yn corresponding to x naught, x1, x2 all the way to xn, and here h is the equal distance from which function, and it is given by x naught minus x1, which is equal to x2 minus x1, which is equal to x3 minus x2 all the way to the last term, which is xn minus xn minus 1. Then x1 will be given by x naught plus 8, x2 will be given by x naught plus 2h, x3 will be given by x naught plus 3h, all the way up to the last value of x, which is xn is equal to x naught n 8. Now, we want p of x to donate a polynomial of degree n. Then this polynomial can be written as p of x is equal to a naught plus a1 of x minus x naught plus a2 bracket x minus x naught multiplied by x minus x1 plus x3 plus a3, this is plus a3 of x minus x naught multiplied by x minus x1 multiplied by x minus x2 all the way up to the last term. Now, we are letting our p of x naught to be y naught, our p of x1 to be y1, our p of x2 to be y2, our p of x3 to be y3, and our p of xn to be equal to yn. Now, we need to determine a naught, a1, a2, a3, all the way to an. So to do that, here, h is given by x1 minus x2, 2h is given by x2 minus x naught, 3h is given by x3 minus x naught, all the way to the last part whereby nh is equal to x naught minus xn minus x naught from the equation above here. So that is where we are getting that. Now, when p of x naught is equal to y naught, we are going to obtain that a naught is equal to y naught by letting p of x naught to be equal to y naught. Now from this equation, number 2, to obtain a1, we are going to let our x to be equal to x1. And when we let our x to be equal to x naught, our a2 will reduce to 0, and our a3 will reduce to 0 because we have x1 all the way to our last value. So that is why here we have p of x1 is equal to y1, which is equal to a1 multiplied by x1 minus x naught plus y naught. Now, so we can take y naught to the other side so that we will have y1 minus y naught, which is equal to a1 multiplied by x1 minus x naught, meaning that our a1 is equal to y1 minus y naught divided by x1 minus x naught. Note that x1 minus x naught is equal to 8. So we can let our y1, which is equal to our y1 minus y naught, to be equal to first one difference of y naught, and our x1 minus x naught to be equal to 8. So meaning that our a1 is equivalent to one difference of y naught over 8. Then next, when our x is equal to 2 from this polynomial here, when our x is equal to 2, the other terms which are larger than all these other terms will reduce to 0, and we shall be left with this part here. Already we have obtained a0 and a1. So substituting the value of a0 and a1 and the value of x with x2, we shall obtain the following. So p of x2 is equal to y2, which is equal to y0 plus, this is the value of a1, which is y1 minus y0, h multiplied by x2 minus x0, that is from here, plus a2 of x2 minus x0 multiplied by x2 minus x1. So from here, x2 minus x0 is equal to 2h, and x2 minus x1 is equal to h. So making the substitution here, substituting x2 minus x0 with the 2h, and x2 minus x2 minus x1 with the h, we shall obtain the following. Substituting x2 minus x0 with the 2h here, we shall have y2 is equal to y0 plus y1 minus y2 over h multiplied by 2h. 2h is the value of x2 minus x0 plus a2 multiplied by h. So h and h will cancel out, and we are going to have y2 minus y0 minus 2y1 plus 2y0, which is equal to a2 2h squared. 2a h squared is equal to y2 minus 2y1 plus y0. Simplifying here after removing the bracket in this part, meaning that now this part y2 minus 2y1 plus y0 is equivalent to second for one difference of y0. On how to arrive with this, check in my previous presentation. You are going to see how y2 minus 2y1 plus y0 is equivalent to for one difference of y0, second for one difference of y0, meaning that our a2 is equivalent to second for one difference of y0 divided by 2 factorial h squared. So what we are going to do now, we are going to substitute our values of a1, which is y0. Our values of a2 is equal to this one. So from the given polynomial, we are substituting this polynomial here, which I'm calling it equation 1. Substituting the values of a0, a1, a2, a3, we are going to obtain this equation here. So p of x is equal to y0 plus this plus all this contact all the way up to the last term. Here we let our u to be equal to x minus x0 over h, which is, so we simplify x minus x1. So we substitute the value of x1, which is x0 plus h, and simplify, and we are going to obtain x minus x1 over h is the same as u minus 1. X minus x2 over h is the same as x minus x0 plus 2h. Those values we and written them up here. They are here. This one, x2 is equivalent to x0 plus 2h. So that is the substitution I'm making use of here. So x minus x2 over h is equal to u minus 3. And similarly, x minus x3 over h, it is equal to x minus x0 plus 3h over h. Simplifying it will give you u minus 3. So we are going to substitute equation A, B, and C in equation 8 to obtain the following result. So making those substitution, instead of x, we are going to obtain x0 plus uh is equal to y0 plus u. First for one difference, y0 plus u bracket u minus 1, second one difference of y naught plus u, bracket u minus 1, multiplied by u minus 2, 3 factorial, that one difference, plus this other part, all the way to the last part. So this is what is referred to as Newton forward interpolation formula. On how to study other interpolations, check on my YouTube channel so that we may study together. Thanks so much for your time. In case you are new, you can check in my previous studies so that you may access this content which has been done for you. Bye bye for now. See you in the next study.